Museum. My name is Joe Noriel. I'm the president. I've seen some familiar faces, so that's always nice to see. Of course, we're right in the midst of Beyond, so I thank you so very much for your support of the exhibition. Certainly something very unique for Petaluma and certainly for California, as we're the exclusive California presenter. So thanks again. It's good to see you all. Really at the heart of our exhibitions are certainly our speaker series, and boy, we've had some incredible speakers so far. And today's no exception. Sorry, we're kind of shrunk in here. We couldn't get the Mac hooked up to the projector, but we'll be as animated as possible to give you a good experience. So first off, we have a big thank you to NASA Ames. They've just been incredible with the speakers that they've been providing to us free of cost, and what a great educational experience for all of us. And we've got one of their top-notch speakers today, no doubt. We have Doris Daou, who's one of their leading folks with public outreach and education. So with that, Doris.
Thank you very much. Thank you all, and thank you so much for having me. And actually, I should say it's really not free of charge. It's your taxes that pays for my job. So you paid for it one way or another. And I really thank you for having me here. It's actually my first trip to Petaluma, and I really enjoyed it. It's such a nice, quaint city. So I would like to just start with my speech. And again, you know, I'm going to try and be as animated as possible. You'll discover that I speak a lot with my hands. And I'll, you know, every time there's a new picture, I'll hold it up a little bit. And feel free to stop me and say, wait for a while, we want to see it even longer. So because I'm going to just try to make this casual, I really apologize for not having the right connections between Meg and others. So as Joe, thank you Joe for having me. So as he mentioned, I work at the NASA Ames Research Center. It's down in Mountain View, Moffett Field. And this building here is where my office is. I personally believe it's the most beautiful building on base. You know, it's the only building that has a tower, a bell tower. We don't have a bell, so and we don't have a hunchback on top, but I'm working on it. So and we are a new institute. NASA created us about 3 years ago. We are known as the NASA Lunar Science Institute. We are a virtual institute, meaning that all our teams are scattered around the country in different universities. This building only holds the central office of our institute. We do research related to the moon, but we also do astrophysical research that we can enable from the moon as well. And we also try to make everybody's so happy. We also do research that we call on the moon, meaning that research of what human exploration would be like. What is the effect of the moon on human exploration, and vice versa? What would happen to the lunar environment if human all of a sudden decided to inhabit the moon? So this is just in short where I come from and where's the place I work at. So, wake up. This is what brought me to work in my field, in astrophysics, the night sky. If you talk to at least 90% of my colleagues, they all will tell you this is it, the night sky. We just love, love, love to go outside, and there's a joke in our community. George is an astronomer, because the minute we go outside, for some reason, the first thing we do, we do our salute to the universe. So, and it's really this what all bring us to. What I'm trying to do tonight, I would like to take you on a trip through the universe and show you pictures, even though on a small screen, but those pictures are one of the reasons that a lot of us are working in our field. We not only try to understand the universe, but also our place into it. Even when we go outside and look out and think of the universe, we try to, how did this get here? How did we become where we are? How was Earth was created? So, home. So as much as we look up on the here, kids. As much as we look up most of the time, we really never forget where we are, where our home is. And one of the things I actually love about my work, I have the privilege and the sheer dumb luck that I'm able to have just casual conversations with astronauts. And every astronaut I have spoken to in my 20 years working with NASA, they tell you, this is what they think of home. This is a beautiful picture. This is the most, in my opinion, iconic picture of the 20th century. It was taken by Apollo astronaut, the Apollo 8 astronauts. And it's very well known. It's famous. If you go on Google, you will see it's one of the most famous pictures of that century. And this is how astronauts think of home, you know, just seeing Earth rise from where they are. But, you know, we went further. NASA has spending a lot of funding into looking further and exploring the solar system. This is another picture that we took a little bit further. There's a spacecraft called Galileo that was sent to study the solar system and get to Jupiter. And this is a picture that Galileo had taken after it passed the Earth. That was taken about almost a little bit less than 4 million miles from Earth. That's the moon. Yes, yes. So, but again, let's look a little bit further. This is still our home. Looks a little bit much smaller, doesn't it? Because it's further. That's true. And this picture was taken from Mars, the Mars rover orbiter. But what I like about this picture, it really, you know, when we feel about Earth, we think about countries. It's like it's a big world. It's not a big world anymore, is it? And we haven't left the solar system yet. And I love to see also the dimension between Earth and the moon in this one. You know, it's beautiful sometimes when we look at night and we see the moon in the horizon, and you have days where the moon seems so large. So this is our neighborhood. This is our neighborhood. We have a lot of the solar system here. This is where we are. So again, the world, it seems that we're going from one place to another. You know, our place in the universe seems a little bit, it is important, but the universe is so much bigger than we thought it is. And if you see that picture, this was an artist's conception, of course. And the picture that's on the triangle with the artist's conception to show you the dimensions and distance and the scale of the solar system. But let's think a little bit. If we think of Earth, our home, and the solar system, our neighborhood, where do we fit? I mean, this is more. When we look out at night, it's really more than just the Earth. This is a galaxy like ours, the Milky Way galaxy. And Earth, the solar system, the sun, is just one dot on its spiral arms. These circles around are what we call the spiral arms. Yes?
It takes about 10,000 years for light to cross from one edge to the other.
Great. Is anybody taking notes?
It's about, I think it's longer than that. I think it's something more like 150,000.
Bottom line is it's a long time.
It's a long, long, long time. All right. So if we're talking about neighborhoods, about home, I decided the Milky Way, I'm going to call it our country. So it's no longer, so my accent for everybody is going to be the same. And I'm not going to go to the next country and think that my accent is very weird. I hope you understand my accent now. But the question is, how did we get here? We have all these galaxies. How did we get here? I mean, the planet Earth, as we see, is just one small place in the whole solar system. How did all this start? My favorite movie. The beginning is a good place to start, isn't it? So in the beginning, we all have heard about, yeah?
The Big Bang.
The Big Bang, great. So we all heard about the Big Bang. We watched it on TV. There are some comedies, I think, talk about the Big Bang. We watched it on documentary. They talk about the Big Bang. We all know that the Big Bang is how the universe started. What happened before the Big Bang? Do we know?
Emptiness.
No.
There's
we
no
don't
way of
know.
knowing.
There's no way. There are a lot of scientists trying to understand what happened in the Big Bang. It's not necessarily going to happen that we don't understand. Did time actually exist before the Big Bang? We don't know. We don't know. So let's start with the Big Bang. Especially if I'm going to try before that, it might take more than an hour for me. So, if we start with the Big Bang, what was happening there? The universe was immensely dense. It was so hot. If you think global warming is a problem, the universe has much bigger problem during the Big Bang. It was immensely hot, immensely energetic, and very, very dense. There was nothing, yes?
all the material in the universe was compressed into a dot smaller than the head of a pen.
Almost. At that time, there was really not real material.
Energy.
I used to tell my teacher when we first studied this, you mean we all started with just hot air? Didn't get the joke, he was a physicist. He said, not really, not really. The universe did not start with air. There were particles, atoms did not exist. Lost the joke totally. Thank you for laughing at my joke. So it actually started with very, very small particles. Atoms did not exist at that time. It was very hot. Exactly, exactly. So it was very hot, and actually took some time. A couple 100 million years. All of a sudden turning 60 doesn't feel so long. So, a couple 100 million years before anything started. Then, the only thing that the universe was doing at this point is expanding. The more it was expanding, the cooler it was starting to get. To a point, it got cool enough for the first atoms to start forming. What atoms? Yeah.
Hydrogen.
Hydrogen.
Helium, deuterium, and a little bit of lithium.
Started with hydrogen. The hydrogen started forming there. The universe continued its expansion. And at that time, gravity started to have a role. So when the helium started forming and gravity started having the role, the particles started attracting, they started getting together, and again, a few 100 million years, the first stars started forming. Now these stars were huge, yes?
And they formed the other materials like carbon, oxygen, and everything.
Oh, it took a while before that.
Inside them.
You know what? You have so many good questions. I'm going to talk to you alone after the talk. How about that? All right? Okay. So, at that time, when the first stars started forming, they were huge. They were really big. They were about hundreds of times the mass of our sun, even more, thousands of times. With that time, the stars started having bubbles around them. They started getting, and gravity started playing a bigger role. They started getting together. The gravity is very important in the formation of our universe. It is at the basis of everything that happened at that time. When the stars started by gravity getting together, they formed bigger bodies that we call galaxies. Now remember, the universe is still dense at that time. So those galaxies didn't have a lot of room to swim around. So what started to happen is they started colliding. And the galaxies, when they collided, they formed bigger bodies, bigger galaxies. Thank goodness what was going on is the universe was still expanding. So it's still more and more room. All of that took about 14 billion years. Not bad. Not bad. It took all that time. And now we see, when we look in the sky, we see all these galaxies that have formed. Some of them are close. The ones that are close have more space because they are at the edge. They have expanded. They had had time. They had had 14 billion years to expand. The ones that we see further at the edge of the beginning of the universe are still in a dense area. And they have a lot of neighbors that are close to them. Now all this started obviously with scientists creating this theory, studying this theory, and think about it. But have we been able to observe anything that tells us all this is right? Who knows about the Hubble Space Telescope? Oh, come on, more than that, don't you? All right, here we go. So one of the experiments that were done were on the Hubble Space Telescope. We decided at this point, this is one of the first telescopes that we had that was so big and which had that kind of capacity in space. And we decided then to observe an area that we called the Hubble Deep Field. Why do we call it the Hubble Deep Field? I'll show you later. But basically, and after that, we wanted to even observe further. So we observed an area we called the Hubble Ultra Deep Field, because we're going even further. But just to tell you how big it is, that small area that we observed is just about 10% of the diameter of our moon. That's how small was this area. Do you think we found anything there?
A lot.
A lot of stuff. just to show you what did it mean for us to observe the Hubble Deep Field and the Hubble Ultra Deep Field. This is the same picture that I showed you in the beginning about the evolution of the universe. Remember when I told you in the beginning it took few 100 million years to form the first galaxies? Well, this is where the Hubble Deep Field helped us observe. The Hubble Deep Field helped us observe that far in the universe, to the edge as closest as we've ever been near the Big Bang. Meaning that we were able to observe some of the youngest galaxies that have ever been created. So, this is what we started with. This is the area that we started to observe. Doesn't show really that much, does it? All right, well, let me see if I'm good at magic. I'm not going to say anything. Can you see? Yeah? The deeper we saw, the deeper we looked, the more we saw. Is it done?
No? No. Okay, I think we're coming up at the final.
Those are the youngest galaxies.
Some of the youngest galaxies. You see those small, tiny little dots that we saw in the beginning? Not only did we see more of them, but we discovered, oh boy, in the beginning we thought, oh, maybe they're stars, you know. They're not. They're big, huge, humongous galaxies. So, and some of those we have never been able to see before. We didn't have the capacities. We didn't have the instruments, you know, with gravity telescopes and such. So this is one of those tiny small squares. Guess how many galaxies are in there?
Several thousand?
10,000 galaxies. So that small little area of the sky had 10,000 galaxies.
And no stars.
Well, galaxies had.
Yeah, but none of ours.
Yeah, yes. So all of a sudden, our big Earth, our big sun, our big solar system, oy. So, and those galaxies obviously were of various ages, various sizes. The ages was different depending how far they were. The sizes also were different. The shapes were different. There were some elliptical, there were some spirals, and the spirals are different. I'm going to show you a lot of pictures about these. So, you know, how far is it far? It's kind of like, are we there yet? You know, are we ever going to see the edge of the universe? No. You know, we've been able to see a lot. We always work on enhancing technology, on enhancing telescopes, and it takes more than one kind of telescopes, you know. The same way when, you know, when you're making a beautiful painting, you need to use more than one color, most of the time. So, I just wanted to show you, before the picture that I showed you, there was a lot of galaxies there. Now with the Hubble Ultra Deep Field, when we decided to even try and look further, try and, instead of just taking the pictures in an hour or two, have a longer exposure to see if we can see more when we do that. Let's see. It's a little bit slower.
So what constellation would we be going into right now?
Right now we're going through it. The constellations are there just to tell us in which directions.
Like,
this,
if you looked up into the sky, what constellation would this be?
this particular shot, it was surrounded, I think, by Sirius. And all these squares that you see, those are different experiments that were led by different primary investigators, different scientists. Each square is a different exposure, meaning the time that it took to collect this data, as well as the instrument. So the closer we look, the closer we're seeing even more galaxies that we've never observed before. So, now we did the Hubble Deep Field. We saw a bit more galaxies. What's next?
Hubble should be.
Guess what? We discovered one of the youngest galaxies ever observed so far. This is one of the images that was taken by the Hubble Space Telescope. 200 million years. This is really a baby. I mean, you know, talking about the terrible twos, that's a terrible twos for a galaxy. Really a baby. Some of the pictures I showed you, these are some of those pieces, bits and pieces in those pictures. Different areas. Look at, remember when I said the universe was very dense? Galaxies really didn't have as much space between them. There were a lot of collision going on. Look at the first image there, to your left. You have 3 galaxies colliding. The image next to it, another galaxy that's colliding with the smaller one, that blue shape there. Do you see that?
Yeah.
So galaxies actually collided a lot, but not all of them did. Look at this one. Very serene, minding its own business. So, as you can see, at that time, galaxies really had different lives than the galaxies, the older ones, the ones that are closer to us. This is the one I told you about that is engaged in a battle with a smaller blue galaxy next to it. One of my favorite pictures about colliding galaxies, I love this one. It looks like a rose. You know, one of the things that you will see with a lot of scientists are still artists at heart. So this is one of my favorite ones. This is an example of 2 colliding galaxies. The bigger one is on top, and the next one now is becoming what we call its companion galaxy. So one of the things we ask each other all the time, so what happens? What's going on? We know now how galaxies, in a way, were created. What they do when they grow up, what's their evolution, but what's happening inside of these galaxies. And again, you know, theory told us things, and we're able to observe them with time. So this is another movie about trying to get, and unfortunately, the beauty of this movie would have been much more enhanced on a bigger screen. But again, you know, in order for us to understand what's going on with galaxies, we, in a way, zoomed in our camera. We wanted to look inside and see what are the processes, you know, because as I mentioned before, this is where stars form, you know, this is where stars form and live. So, we started looking inside of these galaxies. This is one of the most famous ones, M51. Yes. And this galaxy, you have 2 pictures. The red one is a picture that is taken with an infrared camera. And the reason we do that, do you see how the spiral arms that have dark areas? We weren't able to see that with the visible. So what we do is we take the infrared pictures to see what's going on inside of these dark areas. The same way, you know, when you want to spy on your neighbor, as everybody does. So, and what happened is we were able to see these filaments. And we discovered that these filaments, they're not empty space, they're not dead space, they're filled with gas and particles. And they are, some of them, those illuminations that we see around them, those are stars. These are the areas where stars are forming. And they're illuminating the gas and the clouds around them. So I want to show you a few more pictures about inside of galaxies. This is another one that I like, because it really shows you what happens inside. It's really a whirlpool of gas and dust and forming stars inside. And you will see, eventually I'm going to show you something really amazing. Again, you know, it's like having a star-making party in there. And one of the things in the beginning, we used to think that this is, you know, one of my teachers, very well known, Spitzer, was one of the first people that started talking about what exists between a star. Now we call it just interstellar material. And it's basically, you will see that all of these areas, look at this. Like, it's a nursery. have a big cloud, a giant cloud of dust and gas You have stars forming inside. And all this illumination, it's amazing. It's like the stars, while they're forming, they're illuminating all this area around them and forming a lot of artistic shapes. It reminds me, when in the summer, you have some ice cream and, you have sprinkles and then it melts and you have sprinkles all over and the ice cream is gooey. It's kind of like the same thing. But this is another cloud. You see those clouds and it's filled, this is for the Carina Nebula. And you see those features there, the sculptures. These are the sculptures that you see. These are formations that are due to the stars that are around them. Now, who recognizes this image?
The pillars of creation.
The pillars of creation. This actually is a very small detail from the image that I showed you before. And those jets are due to the stars. The power of creation, the power of the star being created is making these really very, don't you think it's very artistic, the way they look? So, this is a few pictures of other examples of stellar creation. They're really areas in nursery for creating stars. And this one, again, is an example. That small inset that's in the bottom is what we call a visible image, which basically a normal image, like when we see each other or the pictures we take. And again, we wanted to see the dark areas, what's going on in there. And we took another picture in an infrared. Look how much more we saw. All these clouds and dusts around the stars. Another one that I like very much, the tripod. And also look, see this one is the visible one. You have this almost star-like shaped dark area where we don't see anything. And then we looked inside it with infrared. Look how much more we saw. All this gas that is helping the formation of the stars around them. The last one. I have to end every single section with a rose picture. This one too reminds me of a flower, doesn't it?
Yeah.
All right, so now we've gone through, we kind of understand how galaxies are formed, how they evolve, how they expand. We also started looking into what happens inside the galaxies, how stars are forming from big clouds of dust and grain, how they expand, how they become a big part of those galaxies. All right, so then what happens next?
The formation of our solar system.
Planets. How is that formation working? The universe is starting to be a very busy place. It's multitasking. Galaxies colliding at the same time, stars are forming, solar systems. Some stars are getting old, and nearing the end of their age, exploding, forming black holes. This is another story though. White dwarfs as well. But let's now focus on how solar systems are formed, because we want to understand how did we get to a planet like Earth. So remember when I said that stars have a lot of clouds around them. Some stars, when they start forming with those clouds, the clouds start having an orbit, circling around the stars. Those clouds are getting bigger. They have dust, And the same way when you have rush hour traffic, you have a lot of cars at the same time, and some of them want to go at a speed faster than another, they start colliding. Not exactly the same thing. My teachers would say that's totally wrong, Doris. But just think of it this way. I'll talk to you later. So, now we have all these particles of dust, remnants of other collisions going on, and circling around the star. They start sticking together. The bigger they get, their gravity starts to pull them around the stars. And you start having kind of a whirlpool there. Some planets are forming, some bigger planets are forming. At the edge, you still have some rocks, some remnants of other collisions happening. You start having, look at this. This is an artist's conception, and eventually you will see in the talk why I keep showing you, for this part, artist conceptions. So at the end, you know, this is what somewhat we understand things look like. Then, you see it in the back? Yeah? It's amazing. Our solar system was born the same way. And only it is when we understood this, then we realized that we still have all these small new planets that we're discovering almost every day now. Well, some of them in our solar system are remnants of this ring around our star, our sun, that before we did not have the capacity. Our instruments were not as strong as they are now. So in a way, what's happening is around our sun, we had that cloud that was turning, and we had remnants of other collision. We had planets that were starting to form, you know, and inside we had the bigger planets, and then at the edge we still have the smaller planets, and we still have that remnants of the ring that you see here. Our solar system still has it. Now, some solar systems still keep a bit more of the cloud around them than others. This one, I would say, is not a toddler, but is a teenager, because not a lot of, you can see, it's not like ours, doesn't have a lot of planets, and it still have a big part of its cloud around it. I want to show you a picture, actually, that shows you what happens really. See those, you have 3 different areas. You see that red area?
Yeah.
This is the cloud that's still forming. And then in the middle you have that star, and then those blue things with bulges around. These are the forming planets that are going around this particular star. So these all, they tell the story of not only how solar systems form, but also they tell us our story, how our solar system forms. And when we observe this, now you hear a lot of NASA missions, you know, like Kepler, you know, which is ran at Ames, and other telescopes, Hubble, and as well the Spitzer Space Telescope, they are all observing what they call new planets. And what we expect from this observation most of the time is we see something similar to this. This is, again, is another artist's conception. You know, you see the star, you see that cloud around, and then you have a planet around it. So this is basically most of the time what we see. However, now I've been showing you a lot of artistic things. This is an actual, real observation. That's how when we observe, we know that this sun has a planet. This sun is a forming solar system. Because not only we see what's going on, we see the cloud disk. Now sometimes the dark areas, those are obstructions. The same way when it's a very sunny day and you have a candle, you see as much of the candle light as if it's dark? Not really. So what we try to do is to be able to see the planet or the effect of the star, we try to obstruct the area when we look at it, of the star itself. Now I'm sure that you may remember at a certain point, they said that for the first time, telescopes were able to observe and have an actual visible proof. Not our artist's conception, not theoretical, not only because we see wobble, you know, which is we see all sorts of variation in the star. We were able to actually see a star that still has its cloud. We were able to see the effect on that cloud that is done, not only the effect of what's going on with the cloud, but the effect that the planets, the forming planets, are having on this star. And this is the picture, is the one with the formal-out debris ring. This is a real image, data that was given by the Hubble Space Telescope. So you see this ring, this is the debris ring that is around the star. And the reason we knew that there's also a planet there is because we saw the bulging areas in the debris disk itself. Do you see now?
Yeah.
I was just saying, these are real observations that we put together. So the movie is a series of the observations. So, now what we understand is how those solar systems are forming, and we know that are similar to our solar system. In a way, it's kind of a looking back and understanding how our solar system has formed. This is also an image that shows us we still have debris that we see around our own solar system. But one of the things that we always wonder is, why do we still study the planets around our solar system? What do they tell us other, obviously, than understanding the geology, what those planets are composed for? Why are they important to our understanding of the rest of the universe, how the universe was formed? Yes?
They help tell us how the solar system formed.
Yes, they do. And most especially, now I do work at a Lunar Science Institute. I have to say something about the moon. And one of my favorite phrases is one that our director used to say, it's not just any moon, it's our moon. So we understand in a way how the solar system was formed. We understood, in a way how stars are formed, how galaxies. We went all the way back to the Big Bang. We still don't understand what happens before the Big Bang. But we know from the creation how the solar system is formed, how most of the planets are. But a lot of questions were around our moon. How was our moon formed? There were 3 different theories that are going on. One of them is simply that when all that disk cloud was going on, the moon formed the same way the rest of the planets did. So basically, they attracted few debris and started going around, and the moon was created with that, the accretion process that was going around the planet. However, there was another theory, is that the moon was captured around the Earth just by the sheer gravity of the Earth. Like, for example, other objects like Phobos and Deimos, for example, or other objects in our source. But there was one theory that now seems to be the one that is the most scientists agree on, is that actually the moon was a result of a giant impact during the formation, during the time where the rest of the planets were formed. And this impact was made by another smaller planet, almost the size of Mars, hit the Earth where everything was going on, and a piece of the Earth's crust got away, and that's how the moon was created. So, what do you guys think? Is it A, the accretion disk? Is it B, just captured by the gravity? Or do you think it's the impact?
All of the above.
Impact.
We're not sure, but we really, really think it's the impact. Well, that's why I love science. You always have a way. You're never wrong, but you're never right. As I said, so now most scientists really agree and think that is actually the impact theory. That the Earth, during the formation, the Earth was hit by a small planet, almost the size of Mars. And the crust of the Earth really was, by that hit, broken away, and that's how the moon was formed. There are many different reasons also why they think that's true, but I'm going to just mention a couple of them. The material, that's another reason why we study the moon. The material that was found was very similar to the rare material that we find on Earth. And another thing, the formation, the actual making of the moon is not really the same as if it was a planet formed from the beginning. It really, the crust of it really shows that it was part of the external crust of the Earth, 25% basically. Whereas for other ones, most planets, it's about 50, the core of those planets is about 50% of the planet itself. So this is another reason why we think understanding of the planets, you know, because most people think, in a way I feel the moon is just overlooked. You know, it's kind of not as well appreciated because we've seen it. It's there all the time, even sometimes when it's cloudy. During the day, during the night, we look up and we continue. We think, it's not as exciting. It's not as like studying a black hole or a galaxy. You know, that's exciting. That's the sexy stuff. You know, it's not like going as far as the edge of the solar system. I don't agree with that. You know, and actually, I started as I started as an astrophysicist. I was born an astrophysicist, and now I really got to understand more. And I was amazed the things you learn so much with the moon. You learn not only about the history of the solar system, but the way we understand. The more we understand the history of our own solar system, the more we can understand how other solar systems were created and were formed. And the more we understand that, the better we are able to observe them and to find them. So sometimes things that are close are not necessarily the things, we've done that. So the moon actually helps us understand not only what happened during the age of our solar system, but really helps us in the understanding of a lot of things in the universe. And this is one of the people in my field, you know, Carl Sagan has a really cornered the phrase saying that we are all made of star stuff. It's more than just a catchphrase, you know. We really are formed, there's nothing. The stars are created, they have in their chemistry, in their making, in their genetic, it's the same thing that what is in our own body. You know, we are truly made out of star stuff. Our bodies have the same elements that are anywhere in the universe. So as much as sometimes the poetry of art is beautiful, we also find that the poetry of science is beautiful. And we still have a lot of questions that we have not answered. Even the questions that we feel we answer. Sometimes we find out, we discover new things. Up to only 3 years ago, only maybe even 2 years ago, none of us thought that we would find water on the moon. Water on the moon. Just 2 years ago, we discovered water on the moon. That changed our understanding. It's back to the books. What does it really mean? The moon is one of the coldest places in the solar system. And it is an amazing time capsule to our solar system. In a way, to the universe. So as much as I really enjoyed being here, and I could talk for hours, I would love to hear more questions from you. And I'm hoping that you guys enjoyed the talk. Oh, thank you.
When will we return to the moon?
To the moon. When we will return to the moon. Well, I'm so glad my boss is here because now she can hear me. Returning to the moon, like everything else, is the scientific decision is compounded with other decisions. And I wish I could answer, but if it was up to me, we need to return to space anyway. If we never built a boat and want to cross the sea, we've never discovered this beautiful country.
Do you know any astronauts that would like to go and live in space?
Actually, the ones I talk to, they all love space. They all love space. For example, now one of our astronauts, John Rumsfeld, who now works as a scientist, because John was an astrophysicist and works as a scientist at Hubble Space Telescope. One of his favorite objects, he's now back to research, and he's doing research on the moon. He's observing and doing research on the moon.
Is anybody ready to go and live there permanently? They go
Yes, I think all astronauts would love to live anywhere in space. Anywhere in space. I remember a talk that our administrator gave a while ago, and he he just hearing them, you know, I'm afraid to be on a roller coaster. So as much as I love space, I just love looking at it. And just speaking with astronauts, it's amazing. It's amazing that somebody is willing to go through, it's not easy, not only the training, just getting out of the Earth orbit.
Don't you miss the green stuff?
Yeah, I think for them, you know, it's the same way I think with sailors. You know, when you, I don't know if any of you also sail, you know, you get to a body of water and you feel like something is drawing you. You love the water, you just want to go in the open seas. And I really think that's what happened with astronauts. For them, it's not the green stuff, it's just space. They just want to go. It's like draw them there. Yeah.
You mentioned they found water on the moon. It's obviously not in the form of liquid water. Is it ice or is it
ice.
vapor? Or
it's ice.
like
About, I think, 2 years ago, right, Shirley? We had a mission that was L-Cross. And this is when they dropped the actual instrument into the moon. And the same way when you drop something, you have a plume. And they observed the material. They studied it. Was, you know, doing spectroscopy and such, and that's when they observed that there's water. Right now it's in the form of ice, especially also that most of it that they found is in the dark areas, the areas that never sees the sun. It's one of the coldest places. Yes?
The moon doesn't have our moon doesn't have an atmosphere, right?
Yes, scientifically speaking, you know, they say it has a very, very, very thin air. However, that, what scientifically speaking would be called an atmosphere is comparable to what here on Earth we do is a vacuum room. So the quick answer is no, but if you really want to be particular, yes, but not really.
Is that true of most moons, of, you know, of other planets?
We're not certain because we haven't done all our observations, but definitely it is not true for all the moons. Yes. Yes?
I have
What?
a question, actually.
Yes?
The ice crystals they found, are they mixed with anything else, any other minerals?
I'm sorry?
The ice crystals on the moon, are they mixed with any other minerals?
Actually, some of them are. Some of them are. And it's one of the things that now the data is still being studied. Finding the water on the moon is one of the biggest breakthrough. Even it's like the same way as the first real observation of a black hole. You know, we've studied and we knew about the existence of black holes for a long, long time. But with ground telescopes, we've had some observation that said, oh yeah, this looks like, you know, the center of this galaxy is a black hole. And the first time we're really able to observe that there's a black hole was with the Hubble Space Telescope. It was a breakthrough. They really exist. Oh my goodness, you know. And with the water on the moon, you know, for the longest time, we thought we knew everything about the moon. And then all of a sudden, oh my goodness. And it was in the beginning, like any new discovery, not only in astrophysics, you know, it was obviously controversial. And that, you know, after 2 years of different observations, different teams realizing actually, indeed, there is water on the moon.
So did they know what it was mixed with, or if it was bound with anything, or was
You know,
it kind of by itself?
Yes, yes, they are, and the paper did, but I'm sorry, I can't.
Well, that's
remember.
okay. I just don't know myself. So.
And I don't want to just say things just
Sure.
because I'm standing here and I'm supposed to be scientist and everything I say
say
is right. Yes?
Do you work with the Chinese scientists since China intends to be on the moon in 2020?
Generally in science, obviously there are a lot of international collaborations. Our institute itself has a lot of international partners. We have, right now, we have Canada, England, Korea. We also have Israel, Saudi Arabia, and the last one we just signed was the Netherlands, and I think Germany. And obviously we know that there is a couple of missions that are lunar missions. The scientists itself, part of our institute and part of other universities. There are a lot of faculty obviously in other universities are not necessarily part of our institute. So there's a lot of international collaborations as well. But as far as official collaboration, it's really not my area, so. All right, well, there are a couple of things I would like to mention to you. We brought some goodies. This is a brochure of our institute. It tells you more about our teams. I think the international partners are, yes, are all here, and it tells you about some of our science. But one of the things I really would like to encourage you very strongly to do, there is an effort that we do every year. It's called International Observe the Moon Night. So every year in the autumn, we pick a different date. This year is October 8, 2011. We have a big, big star party all over the world. Last year, we had about 500 events in about 53 different countries. And the website that is on this card has all sorts of activities that you could do. You don't necessarily need to do this with a scientist. You know, all you need to do, and I keep telling the scientists, do your neighbor know what you do for a living? You know, knock on their door. It's a really true star party. You can go, you can register your star party. That way, if you are having one in your neighborhood, people in the neighborhood can go there and say, oh, you know, our neighbor are having a moon night star party. It's a really wonderful event. And what we're trying to do is to engage people to go out. I like television, but that night, go out and look at the moon. And the actual website, if you want to look at specific things, could tell you interesting features to look at the moon. We'll also tell you during that evening which planets are visible. Also, we have a lot of collaboration with amateur clubs. If you have an amateur club in the area, I'm sure they're holding something, and if not, call them and say, how come you're not? So please take a look and just go out and observe the moon. And for the kids at heart, I have some lunar tattoos that I like too, and some stickers. So please feel free to take as many as you'd like. And thank you again for having me.
Thank you.